Okay, let's just get into this. This is first missing positive. It's a level hard LeetCode question. But this is actually a level easy question, except that they throw in this like little curveball of asking for you to return an algorithm in O of 1 auxiliary space. O of 1 auxiliary space is essentially how something is stored in memory, and so it has to return an O of 1, which is instant. O of n is that the input grows proportionally with the list grows proportionally with the input. So what they want you to do in this type of question is essentially use the list that they provided. But I'm gonna do the easy method first. Don't know why I keep disappearing. And it's really quite simple. You just use a set. So let's just set temp equals to set nums. And then we're just gonna make I equal to 1. And then while I in temp, just check if it's in there, return. Oops, sorry, we're gonna iterate through it. And then we're just gonna return I. So this is what this answer to first missing positive is. You'll see that it will come back with all the cases accepted, and for some reason when I submit to LeetCode, it accepts it, and then sometimes it doesn't, which I have no idea why, because this algorithm isn't an O of 1 auxiliary space. So I'm gonna show you the other way of how to do it, which is the proper way of doing it. So first of all, we would create a variable called n, which is equal to the len nums, the length of our number list, of our nums list. And then we're going to create a for loop. So for I in range and the range of our nums list, we're going to throw a while loop, okay? And we're going to have two conditions to ask. So while our number is not a negative, so it's greater than 1, and that's where we're going to put our number that needs to be judged, and it's less than the actual length, so it doesn't go over, okay? And we know that because in this example, the smallest number is 7, yet the output is 1. It means that the entire length of this list, this n would be 1, 2, 3, 4, 5. The number 5 is not present in this list, so it automatically returns 1, okay? So in order for this loop to go, for this while loop to even start, it has to be in the range of 1 and the maximum length of the lens, okay? So and our second condition is if nums I, so this is a kind of a tricky thing, but basically this is asking for the index. So nums I minus 1 not equal to nums I. So what this is doing, right? Let's say nums I in this situation is, let's just say the value of what's in this nums I is a number 3. Okay, let's say you have like 1, 3, 4, 5. Okay. So this value is a 0, right? So, but within this list, this element is 3. Okay. So this would be 3. The value of 3 minus 1 would equal to 2. So then we would check 0, 1, 2. And it's checking if at this position, if it's the number 3. Okay? And it's not, so this would return a wrong. This would return a false. What we're trying to do is basically, because arrays start at 0, you want to take the value of an element and then subtract it by 1, because that's where it's supposed to be, and its position is, that's what its position would be in the index. So the value of 3, if it was in a sorted array, should be in the index of 2. So what we do now is we just swap. We would swap this number with this number. So let's take this number right here. Let's just copy it for time's sake, right? We're gonna just do this little trick. We just swap by doing this and then this. So we're switching the values out, okay? And then after this while loop, we're going to do another for loop. Same thing for I in range. And what this is going to do, right, is going to check if we would have to do if num's I, so if the value we're at is not equal to I plus 1. Okay. What this is let's say the value of 3, like we had in our list, is not equal to I plus 1. So let's say this I is at index 2, that'd be the number 3. This is checking if the value within the value of the element is the same as the index. If it's not, then return, we're just gonna I plus 1. If not, we're gonna, that means if we've gotten everything correct, then we have a sorted list, and the smallest number would be the number that comes after the final element in the list. So that would mean that we'd have to return n plus 1. Let's see if this goes through, if I didn't make any mistakes. Oh, that's already a mistake 1, misspelled. Oops, and look, I did it again and again and again and again and again. Come on, man. It's very late in the day. Okay, so this is accepted, and when we submit, because we've gone through the list and we just simply swapped, this is an O of 1 algorithm. So it passes the O of 1 auxiliary space constraint, and it gives us the same value as if we used just a simple a set, but we're not allowed to use a set because that would make a set grows in O of 1 time and space constraint. So we need an O of sorry, I'm all over the place. It grows in an O of n, but we need it to be O of 1. So this was simply just going through the list that existed that was provided for us and just swapping, and then just checking at each loop. This is a tricky question because you need to know how to reverse it if it's to make it O of 1 auxiliary space. This was very challenging for me to understand, but yeah, it works.